Okay, dear friend, we will start to new title in discrete math as an algorithm. Okay, algorithm. So first of all, in computer or software engineering, there is so many problems, can be solved by considering them as special cases of general problems. Actually, discrete math also will help you solve some, algorithmic problem in software engineering or computer science area. Like what? Basically, you can say or commonly you will see this kind of problem locating the largest integer in the sequence, like 1, 0, 1, 12, 144, 212, and 98. This is a specific case of the problem of locating the largest integer in a sequence of integer. To solve, if we want to solve this kind of problems, we must give an algorithm. Like what? Like what? Which specifies a sequence of steps used to solve this general problem, this kind of problem. So algorithm is giving the, kind of basic or easiest way, considering our, ability or our task. So this is the basic approximation. So if you want to define what is the algorithm, okay, an algorithm is a finite sequence of precise instructions for performing a computation or for solving a problem. So we define the algorithm and we define, also we wrote the definition of algorithm. So which kind of thing can be example in this area? If you want to write as an example, actually we define one inside of our definitions and explanations, and an algorithm, for example, for finding the maximum. Maybe you can say largest. If there is an absolute value number, you can say is the largest value in a finite sequence of integers. So this is a very famous example. Finite sequence of integers. So we can say this kind of example. Also, to explain to how we can, represent to explanation of this kind of algorithm, or how we can code. So there is the easiest way as a pseudocode. So what is the pseudocode? In computer science, or generally we can say in computer science, like software engineering is also part of computer science. Pseudocode, okay, we correct here, pseudocode is a plan language description of the steps in an algorithm or another system. And pseudocode also often uses structural conventions of normal programming language, conventions of a normal programming language, but is intended for human reading rather than machine reading. So basically you can say there is the flow chart and pseudocode, meaning of the draft of the coding, and we can write behind that explanation, finding as an example, pseudocode example, you can find basic instruction of the pseudocode from the internet, and I'm gonna write here as an example what we wrote upside, finding the maximum value in the sequence. Okay, example algorithm finding the maximum element in a finite sequence, of course finite sequence, otherwise we will do some kind of approximation as the infinite condition, and there is the procedure as a maximum sequence A1, A2, and so on, AN as an integers of the sequence, then max A1, if A1 is the maximum value in that sequence, so for I is equal 2 to n, this is the indices of the sequence, if, so there is the condition as a max AI, then this is the comparing of the second value and what we have as a first value in the maximum integer, then return max, then we will have as a max is the maximum value of that integers, and max is the maximum or largest element of that sequence. So this is the pseudocode to find maximum value of the sequence, integer sequence. Of course, it is a finite sequence. So what else about the algorithms with the new page? Properties of the algorithms. Okay, there are several properties that algorithms generally share, so they are useful to keep in mind when algorithms are described. So what are those? As the first one, okay, input. So algorithm properties, first one as an input. An algorithm has input input values from specified set. So we have an input, and second one, of course, we have to have output from each set of input values. An algorithm produces output output values from a specified set. The output values are the solution or result to the problem. Okay, let's say like that, to the problem. So we have output, and what else? And definiteness, the steps of an algorithm must be defined precisely. And what else? Correctness, an algorithm should produce the correct output value for each set of input values. And finiteness, and an algorithm should produce the desired output after a finite number of steps for any input in the set. And effectiveness it must be possible to perform each step of an algorithm. Exactly, and in a finite amount of time. And I think last one. As a generality, the procedure should be applicable for all problems of the desired form, not just for a particular set of input values. So these are the properties, and so algorithm properties, and what we have as a type of the algorithm. Let's look at these, then we will continue to complexity of the algorithm, and we will look some detail also. And searching algorithm, we can classify type of algorithms. So we can say as a searching algorithm, let's say searching algorithms. A program that checks the spelling as an example, or some approximation to give the idea of word, search for them in a dictionary, which is just an ordered list of words, list of words. So these type problems are called searching problem, and using this kind of problem, there is an algorithm which is searching algorithm. So we saw as a first type of algorithm as a searching algorithm. There is some kind of subclass. There's some kind of subclass of searching algorithm which are as a first A or B or one, and the linear searching algorithm, and second one binary searching algorithm. And maybe you can add some kind of approximation for searching algorithm. And as a next, we can say as a sorting algorithm in the new page. Sorting algorithms. Sorting algorithm. Okay, let's try the definition. Okay, previous page. Okay, why you need so that like that, Zeynep? Writing your own note? Okay, go ahead. Anyway, sorting algorithm is taught to hold the record. I'm sorry, record, record as the problem solved by the different or most fundamentally different algorithms, different algorithms. So you know meaning the sorting, and there is some kind of sub approximation of the sorting algorithm as a bubble sorting and insertion sort, also bubble sorting, insertion sorting algorithm. And next one, Yeah, there is also more algorithms, but let's continue to write all definition as an algorithm. And sorting algorithm. So what is the general definition of the sorting algorithm? Is ordering the elements of a list is a problem that occurs in many contexts. Many. For example, to put to produce a telephone directory, it is necessary, of course, it is necessary to alphabetize the names of subscribers. So creating a useful dictionary, of course, dictionary, because we are using the sorting of the words, requires and rules that words be put in alphabetical orders. So if we will put, we have a sequence and we want to make that sequence in kind of order, like the words in telephone directory. There is the name of the account from the system, and then we need to require kind of we need to put the name in kind of order. So this kind of ordering is also sorting algorithm. And there is the bubble sort as a type of the sorting algorithm. The bubble sort the bubble sort is one of the simplest sorting algorithm, but not when we look at the efficiency, but not one of the most efficient. So it puts a list into increasing order by successively comparing adjacent elements, interchanging them if they are in the wrong order. So as an explanation, to carry out the bubble sort, we perform the basic operation that is interchanging a larger element with a smaller one following it, starting at the beginning of the list, doing one time and starting at the beginning of the list for full path. So we have to iterate this procedure until sort is complete. So this is the weak point of that algorithm. If you couldn't complete in one cycle or one pass, then you have to start again beginning of the list. So this is disadvantage of the algorithm. Okay, example. I have example. I will try to write. Okay, use the bubble sort to put, and we have a, a sequence as a inset A, 3, 2, 4, 1, and 5 into increasing. Okay, this is what we want, into increasing order. So as a solution, so we have that list as a 3, 2, 4, 1, and 5. In computer, in that array, as a first element is 3, 2, and next one, and 4, 1, and 5. So sorting algorithm, changing the place of according to changing the place of first pass. Then we want to increasing. Then it is repeating itself again and again. So we have beginning list form as a 3, or we can use like that. Okay, 3, 2. Okay, I'm gonna use like the column matrix 3, 2, 4, 1, and 5. First pass, I will change that two elements because I want the increasing order. And here is going to be 2, 3, 2, 3, and 4, and 1, and 5. So this is my first passing from that sequence. I changed that 2 element place, but now I'm comparing 3 to 4, 3 to 4. So I don't need to change that one. So I have again 2, 3, 4, 1, and 5. Okay, I checked here. So I have to change the place of here. The 2, 3, 1, right? 4, and 5. I checked here. So I said that's okay. This is the first pass or first check. So I have to repeat that issue as a second pass. I have as a list 2 or set 2, 3, 1, 4, and 5. I checked here. I don't need to change any place. 2, 3, 1, 4, and 5. I checked here. I have to change. That's why I'm using the arrow. Then I will have here 2, 1, 3. Each step I'm passing the next step. I'm not checking again. One should be the first element of that sequence. 2, 3, 2, 1, 3, and I have 4. I will check here, so I don't need. And 5, one more, 1, 2, 1, and I'm checking here. No, because my point is downside. I check here, so I don't need any change. This is the second pass. So I have kind of, pointer. I'm checking that 2 element and changing, then repeating 2, 3, 4. Is there any operation need? No. 3, 4 is increasing order, and 4, 1, I'm checking 4, 1, and then changing the place 1, 4. Then I'm continue to check increasing order. There is no need to increasing because 4 is less than 5 and 4, 5. And here is the second pass. I don't need to change the interchanging the place of the 2 and 3. 2 and 3 is gonna be same place, but when I check the 3, 1, I have to change their place. 2, 1, 3, and I have to check 3, 4, there is no need, and 4, 5, there is no need. This is the second pass. Algorithm repeat itself as a secondly, and third one, I have 2, 1, 3, 4, and 5. So when I checked here, I had to change the place because I need here is a 1, 2, right? 1, 2, 3, 4, and 5. I interchange the place of 1 and 2, and I'm checking 2 and 3. I don't need. Then 1, 2, 3, 4. I don't need any change here. 1, 2, 3, 4, and 5. And I don't need here also. Now you see I completed ordering to that list or that sequence using the bubble sort. Any question for bubble sort? This is easy, right? So we can say here as an explanation without using the dot node and interchanging and if we put that sign, correct order. Okay, that's it. And next one, what we have. Thank you, Emre. Okay, we can write the this is the page 3. There is the bubble sort pseudocode. Can we put here or we need new page? I'm checking. Okay, new page is better. Okay, page 3 and pseudocode of that example. Okay, again, procedure, bubble sort. And we have A1, A2, and so on to AN. Of course, this is the infinite sequence. There is the real number with and less than 2. And for I is equal 1 to n minus 1, and there is again second for j is equal 1 to n minus I if ij greater than ij plus 1, interchange ij and ij plus 1. Then we will have, according to that iteration, we will have I1, I2, In, is in increasing order. Okay, I want to give a break, then I will continue, sorting algorithm, but it's going to take some time. Okay, dear friend, let's do break and then continue.